Good morning, dear students. In our last lecture, we have talked about important reasoning questions for group 15 elements, that is your nitrogen family. There, you have to remember one more point, that nitrogen belongs to second period. So its valence shell is second shell having electronic configuration as 2s2 2p3. There are 3 unpaired electrons present in nitrogen. As it is a member of second period, as it is having valence shell second, so in nitrogen d orbital is absent, because for second energy level we never have d subshell. So nitrogen cannot expand its octet. The maximum number of unpaired electrons that can be present in nitrogen is always 3. So nitrogen will never expand its octet. That's why it does not form NCl5. Because for the formation of NCl5, we require 5 unpaired electrons in nitrogen, which is not possible due to absence of vacant d orbital. But if we talk about phosphorus, then phosphorus can form pentahalide like PCl5. The electronic configuration of phosphorus for outermost shell is 3s2 3p3. And if we talk about third energy level, then for third energy level 3d is possible. So in phosphorus, 3d subshell or 3d orbitals are vacant. Phosphorus is having 3 unpaired electrons in 3p orbital. In 3s, there are 2 electrons which are paired. Now suppose if phosphorus want to form pentahalide PCl5, then phosphorus must have 5 unpaired electrons. So what will happen? One electron from 3s will be excited to 3d vacant orbital, as a result of which 5 unpaired electrons will be created. And we can say phosphorus can expand its octet. It can have more than 8 electrons after sharing. 5 plus 5, it will be having 10. So due to presence of vacant d orbital, phosphorus can form pentahalide like PCl5, but it is not possible for nitrogen. Nitrogen can form NCl3 only. NCl5 is not possible for nitrogen, but if we talk about phosphorus, phosphorus can form PCl3 as well as it can form PCl5. Now let us move to group number 16, which is called oxygen family or chalcogen family. Chalcogen stands for ore forming. In most of the ores or in most of the minerals, oxygen atom is present. If we talk about hematite, Fe2O3. If we talk about magnetite, Fe3O4. If we talk about calamine, it is ZnCO3, etc., etc. So in most of the minerals, oxygen atom is present. That's why it is called chalcogen family. Now, their general outermost electronic configuration, because it belongs to, the members belongs to 16 group or 6A, 16 minus 10. Total valence electrons will be 6. Total valence electrons will be 6. 2 electrons in NS subshell and 4 electrons in NP subshell. In total, there will be 6 electrons. And the members are oxygen, sulfur, selenium, tellurium and polonium. Polonium here is a radioactive element. It emits harmful radiations like alpha, beta and gamma. Again, oxygen belongs to second period. Its electronic configuration is 2s2 2p4. In oxygen also, d orbital is not possible because for second energy level we cannot have d. It means oxygen also cannot expand its octet. While the other elements like sulfur, selenium, in all these elements vacant d orbital is present. So these elements can expand their octet. So they can have more than 8 electrons after sharing of electrons. But oxygen every time will be having 8 electrons after sharing. Now, important point. Whenever we talk about oxygen family, then oxidation state of oxygen is very important. In class 11th we have discussed in redox reaction that oxygen in most of the compounds exhibit -2 oxidation state. And if it is exhibiting -2 state, that is called oxide. Oxygen can also exhibit -1 oxidation state. And if oxygen is exhibiting -1 oxidation state, then it is called peroxide. Oxygen sometimes can also exhibit -1/2 oxidation state. So if oxygen is exhibiting -1/2 oxidation state, then it is called a superoxide, like KO2. KO2 is called superoxide. Na2O2, it is called sodium peroxide. Na2O, it is called sodium oxide. So in oxygen, we can have -2 oxidation state most of the time. With few cases, it can be superoxide, where oxygen will exhibit -1 oxidation state. And with potassium, it will form KO2, where oxygen is exhibiting -1/2 oxidation state. So when oxygen is exhibiting -1/2 oxidation state, then it is called superoxide. Oxygen is the second most electronegative element of the periodic table. First one is fluorine. So if fluorine is not there, if F is not there, then oxygen in all the cases will exhibit minus oxidation state, negative oxidation state, because it is the second most electronegative element. It can attract the electron from the other atoms. But when it forms compounds with fluorine, the most electronegative element of the periodic table, then with fluorine, oxygen will exhibit +2 oxidation state, and it is only with OF2. So this is about the oxidation state. Then comes the next part. If we talk about the physical state, then oxygen is a gas while other elements are solid at room temperature. The physical state depends on two things. First, the atomicity of the molecule. How many atoms are there in a molecule? And second, the force of attraction present between the different molecules. If we talk about oxygen, oxygen is diatomic in nature, O2. There is a double bond present between oxygen atom, means oxygen is forming p-pi bonds. Pi stands for double bond, p because p orbital is involved. Due to small size of oxygen atom, oxygen is able to form p-pi bonds. So there are only two atoms in oxygen molecule. With the increase in number of atoms in the molecule, with the increase in atomicity of the molecule, the physical state changes. It can be from gas to liquid, or it can be from liquid to solid. So in oxygen molecule we are having p pi bond due to small size, and at the other end the force of attraction that exists between oxygen molecule is weak van der Waals forces of attraction. Both the factors make oxygen a gas at a room temperature. But for the other atoms, their size is more. If the size is more, then formation of double bond is not easy. It is easy if the atomic size is less. Oxygen is the first member of the group having smallest atomic size, so oxygen can form double bonds and it exists as a diatomic molecule, but it's not possible for the other elements, other atoms. They have more size. Double bond is not stable with the atoms having more size, so they form single bond and they exist in the form of puckered ring-like structure. Like sulfur, sulfur exists as S8 molecule. Atomicity of sulfur is 8 at room temperature. It is an octatomic molecule. So due to presence of more number of atoms, the force of attraction that exists between the atom is more. That's why sulfur is a solid at room temperature. Then comes next point about the hydrides, means combination of these atoms with hydrogen. All the atoms are having 6 electrons in their valence shell. By gaining 2 more electrons, they can complete their octet. Hydrogen is having only 1 electron. Oxygen, sulfur requires 2 electrons for the completion of the octet. So here we can say that the formula of the hydride will be MH2 type, like H2O, H2S, H2Se, H2Te, etc. And all these hydrides are covalent in nature because the bond is formed by sharing of electrons between hydrogen atom and the atoms of group 16. These hydrides are covalent in nature. Now, if we talk about the physical state, then H2O is a liquid while others are gases at room temperature. Let us compare between H2O and H2S, water and hydrogen sulfide. There is a concept that boiling point is directly proportional to molar mass. If molar mass is more, boiling point will be more, physical state will be liquid. If molar mass is less, boiling point will be less, we can go for solid state. But here if we talk about H2 and H2S, water and hydrogen sulfide, the molar mass of hydrogen sulfide is more than H2O, but still H2S is a gas while H2O is a liquid. What is the reason? Reason is very simple. In H2O, H bonding is present. In water, water molecules are associated via H bonding. Extra bonding is there. More force of attraction is there between the different molecules due to presence of H bonding. So due to presence of H bonding, water is liquid at room temperature, while in H2S, H bonding is absent. Remember, for H bonding, 3 atoms are responsible: fluorine, oxygen and nitrogen with hydrogen. When H atoms comes in between fluorine, oxygen, nitrogen, then there is development of H bonding. With H2S, it is not possible. That's why H2S is a gas at room temperature. Then comes next point about their acidic character. These are weakly acidic in nature. Remember, water is neutral. The pH of water is 7 at room temperature. Or in other words, we can say that in pure water, the number of H plus ions are always equal to number of OH minus ions. That's why the pH of water is 7. We can say water is a neutral compound. But for others, we can say these are weakly acidic in nature. Now if acidic character is compared, between the different hydrides, then as we move down in a group, the acidic character increases. So what is the order? Acidic character of H2O is less than H2S. Acidic character of H2S is less than H2SE. Acidic character of H2SE is less than H2PE. It means as we are moving down a group for hydrides in group number 16, then the acidic character increases. The reason is very simple. Acidic character is decided by the presence of H plus ions. If a compound can form H plus ion, then it will exhibit acidic property. If release of H plus ion is easy from a compound, then it will show acidic character. Now let us compare. Oxygen is the first member of the group, so it is having least atomic size. So here is a bond between H and O. Bond length is less, so bond strength will be more. Release of H in the form of H plus ion is not easy because bond strength is low. It is difficult to cleave a small bond. But as we move down in a group, after oxygen it is sulfur. Atomic size of sulfur is more than oxygen, so naturally bond length will increase. If bond length will increase, then the force of attraction between H and sulfur will decrease. Or in other words, we can say bond strength will decrease. So bond strength is proportional to 1 by bond length. With the increase in bond length, bond strength decreases. So here bond strength is less due to more bond length. Why the bond length is more? Because atomic size of sulfur is more than oxygen. So cleavage of HS bond is easy. So H can be released in the form of H plus ion easily if it is compared with the OH bond. Now as we move down, bond length will further increase, which increases the acidic character, which increases the acidic character. So H2P is having the maximum acidic character and H2O is having the least acidic character. Then comes the next one. Fluorine forms hexahalides with sulfur. Means we are talking about SF6. Sulfur can accommodate 6 fluorine atoms at a time, but it is not possible for other halogens. It is not possible that here we can have 6 Cl. It's not possible that here we can have 6 Br. Here it is not possible that we can have 6 iodine. So only fluorine can form hexahalide with sulfur. What can be the reason? Reason is very simple. Sulfur is having 6 valence electrons, and if sulfur wants to form hexahalides, then sulfur must have 6 unpaired electrons. But in sulfur, in ground state, we are having only 2 unpaired electrons, and the 2 unpaired electrons are present in 3p orbital. So how to get 6 unpaired electrons? Reason is very simple, and reason is high electronegativity of fluorine. Due to high electronegativity of fluorine, fluorine can cause unpairing of electron in sulfur atom. So here is the ground state for sulfur. 3s to 3p4. 2 electrons in 3s and 4 electrons in 3p. Sulfur is having only 2 unpaired electrons. For the formation of hexafluoride, we need 6 unpaired electrons. This is the ground state electronic configuration for sulfur. Now what fluorine? Being the most electronegative element of the periodic table, it can cause unpairing of electrons in sulfur. So what will happen? Paired electron will be excited to higher energy level state, that is 3D. Electron will be jumped to here. We'll be having 1, 2, 3, 4, 4 unpaired electrons. This is called first excited state. So sulfur can form Sf4 because it can have 4 unpaired electrons. Now for getting 6 electron, one more electron from 3s will be migrated to 3d, will be excited to 3d. So when this electron is jumping to 3d, we will get 1, 2, 3, 4, 5, 6. 6 unpaired electron, and this is called second excited state of sulfur. So unpairing in sulfur, creating 6 unpaired electrons in sulfur is only possible by fluorine, as it is the most electronegative element of the periodic table. It is not possible for chlorine to get second excited state where 6 unpaired electrons are there. Size of fluorine is less. As we move down in a group, size increases, electronegativity decreases. So this is the reason fluorine can form hexahalide sulfur, but it is not possible for fluorine, bromine and iodine. That's all in group 16 reasoning question. Tomorrow we will start with group 17 elements. Thank you and have a nice day.